Hello everyone, I'm an avatar developed by Yili Lin, a PhD student in health services research at George Mason University. In this session, we will cover how to interpret the results of ANOVA, analysis of variance, in R. Key elements of ANOVA output include degrees of freedom, sum of squares, mean square, f-value, p-value, and significance codes. In the first part, we will focus on details regarding degrees of freedom and sum of squares. Both one-way and two-way ANOVA calculate total degrees of freedom, df, as n-1, where n is the total number of observations. In one-way ANOVA, the between groups degrees of freedom is calculated as k-1, where k is the number of groups, representing the comparison of group means. In two-way ANOVA, the degrees of freedom is divided between factor 1 and factor 2, as it considers two independent variables. The degrees of freedom for the supplement factor, with two levels, is 1. In one-way ANOVA, the within group's degrees of freedom, n-k, represent the variability within each group that is not explained by the factor being tested, where n is the total number of observations and k is the number of groups. Here it is 58, indicating 60 total observations, as 60 minus 2 is 58. In two-way ANOVA, degrees of freedom are calculated as n minus a times b, where a and b are the levels of factors 1 and 2. This measures unexplained variability within each factor combination, accounting for interaction effects, like in one-way ANOVA, but considering both factors. In this case, there are two levels for both factors, supplement and dosage. It is 56, indicating 60 total observations, as 60 minus 2 times 2 is 56. In two-way ANOVA, the degrees of freedom for each factor represent the number of comparisons between its levels. For factor 1 with A levels, degrees of freedom is equal to A minus 1. The same applies to factor 2. In this example, factor 1 and factor 2 each have two levels. The degrees of freedom for both factors would be 2 minus 1 is 1. The degrees of freedom for the interaction between factor 1 and factor 2 is calculated as A minus 1 times B minus 1. It tests whether the effect of one factor depends on the level of the other. In this example, with two levels for both factors, the degrees of freedom for the interaction is 2 minus 1 times 2 minus 1 is 1, indicating one independent comparison to assess factor interaction. The total sum of squares, SST, in one-way and two-way ANOVA represents the overall variation in the data, calculated by comparing each observation to the overall mean. It forms the basis for assessing how much of the total variation is attributed to the factors being studied, with the formula being identical in both models. In one-way ANOVA, this component quantifies the total variation explained by differences between groups of a single factor, capturing variability among the groups. In two-way ANOVA, the variation between groups is divided into SS for factor A, variation due to the first factor, SS for factor B, variation due to the second factor, interaction SS, variation due to the interaction between the two factors, showing how their combination affects the dependent variable. This approach provides insight into how two factors and their interaction explain the variation. In one-way ANOVA, the within groups SS indicates the unexplained variation within each group, often seen as random error or individual differences. It is also known as the error or residual sum of squares. The within groups, SS, in two-way ANOVA quantifies the residual variation within each subgroup defined by the combinations of factor levels. It captures the variability not explained by factor A, factor B, or their interaction. The sum of squares for the supplement factor is 205, indicating the variation in the response variable due to differences between groups defined by the supplement. The residual sum of squares is 3,247, representing the unexplained variation, or error, within the groups. In a two-way ANOVA, the sum of squares for the supplement factor is 205.4, indicating variation due to differences between supplement groups. The dosage factor has a larger sum of squares at 2,224.3, showing it significantly contributes to total variation. The interaction between supplement and dosage has a sum of squares of 88.9, reflecting the variation explained by their combined effects. The residual sum of squares is 933.6, representing unexplained variation or error. Please refer to the second part for more details on the mean square, f-value, p-value, and significance codes.